everyone. In this class, I'm going to explain the concept functions for moments. We know the moments are of two types, moments about origin and moments about mean. We have seen already those two types of moments. The formulas used in those concepts for finding the moments are direct formulas. Here, especially to find the moments, we have two functions. The two functions are, the first one is characteristic function and the second one is moment generating function. These two functions are used to find moments of any order. And why we are going for these functions for moments, we have already the direct formulas. The thing is, with these concepts, we can find the moments in an easier way. Okay, let us start the first thing. The first thing is characteristic function. Okay, the characteristic function of a random variable x with the probability density function fx of x is represented by fx of omega. The characteristic function is represented by fx of omega, and that is expectation of e power j omega x, where this capital X is the random variable. Okay, then how to write this expression? Yes, what is expectation of e power j omega x is nothing but, I am writing the general formula. Expectation of e power j omega x is integral minus infinity to infinite a power j omega x into fx of x dx. Because we know the expectation of x is integral minus infinity to infinite x into fx of x dx. Yes, in the place of small x we have here e power j omega x. Simply you write e power j omega x in this portion. Okay, so this is your characteristic function phi x of omega. I can say this is the formula for continuous case. The same formula is sigma I is from 1 to n e power j omega xi p of xi is the formula for discrete. Yes, now if you observe this formula, is nothing but the Fourier transform of the density function fx of x with the sign of omega reversed. Yes, what is this Fourier transform? Fourier transform is nothing but, see this, suppose if we want to write the Fourier transform of the function f of t. The Fourier transform is represented by f of omega. Yes, f of omega is equal to integral minus infinity to infinite f of t into e power minus j omega t dt. Okay, if you compare this and this, yes, what is the difference? Here the function is f of t, here the function is density function. Okay, instead of e power minus j omega t, here it is e power j omega x. Okay, yes, then here if you observe the difference, only the negative sign is the difference. So you can consider this function as the Fourier transform of the density function fx of x with the sign of omega reversed. Okay, and another point is, if this is the Fourier transform, the inverse Fourier transform is also there. Inverse Fourier transform of this function is nothing but your f of t, where f of t is equal to 1 by 2 pi integral minus infinity to infinite f of omega into e power j omega t d omega. Okay, this is the Fourier transform and this is the inverse Fourier transform. You can see these two in the signals and systems concept. Okay, so here see this, inverse Fourier transform apply chesthe meeku em vastundi, tirigi mee function vastundi. Okay, now with this formula what you can write? Yes, see this, what is this? This is the Fourier transform of the density function fx of x with the sign of omega changed. Suppose if you want to write the same density function again fx of x, simply what you have to apply? You have to apply this inverse Fourier transform. So if you apply inverse Fourier transform, you will get fx of x is equal to 1 by 2 pi into integral minus infinity to infinite this characteristic function phi x of omega into e power minus j omega x d omega. So here also if you observe, the equation is same, but here only the sign of omega is reversed. Okay, you can use this formula to get the characteristic function, and From the characteristic function, if you want to retry your density function, you have to use this formula. Okay. So now, what is the characteristic function? The characteristic function is transforming the random variable x into another variable omega. See this is phi x of omega. It is in terms of omega. So, if you apply the characteristic function concept here, it will change the random variable x into another variable omega, where omega is a real number which varies from minus infinity to infinite. Okay, omega is a real number which varies from minus infinity to plus infinite. Okay, so this is about characteristic function. Yes, how to find the moments? Here we have a formula for moments. The formula is what is that? Finding moments is we have a formula for the nth moment. Nth moment mn is equal to minus j power n d power n phi x of omega by d omega power n at omega equal to 0. Yes, we can derive it. We can derive this formula. So, we will go for derivation. Yes, I will start with the characteristic function phi x of omega. What is phi x of omega? Expectation of e power j omega x. Fine. Yes, now we are expanding this e power j omega x using the series expansion of this e power j omega x. Yes, what is that equivalent expansion? We can write e power x. Yes, you can take it as a note point. Okay. You can write e power x as 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on x power n by n factorial. Okay. So now I am applying this formula here. So it implies phi x of omega is equal to expectation of 1 plus, what is x here? X is the total j omega x. So the first term is j omega x plus the next term is j omega x whole square by 2 factorial plus j omega x whole cube by 3 factorial and so on j omega x whole power n by n factorial. Okay, therefore, yes, say this is phi x of omega is equal to, yes, e of 1 plus j omega x minus omega square x square by 2 and then j cube and then minus j avutundi minus j omega cube x cube by 3 factorial means 6 plus and so on plus j power n omega power n x power n by n factorial. Okay. So now I am applying expectation for each and every term. E of 1, yes, e of j omega x minus e of omega square x square by 2 minus e of j omega cube x cube by 6 and so on. Yes, you can leave that last term, no problem. So now see this. What is e of 1? Expectation of a constant is constant. Yes, manki properties of expectation lo chusam. Tarvata omega are not the random variables. They are, this is j is imaginary and omega is the real value. So j omega you take outside. So expectation of x remains. The same way here minus omega square by 2. Then it is e of x square. Okay. Then minus j omega cube by 6 e of x cube and so on. So now 1 plus j omega. What is e of x? m1. Okay. If you want, you can verify this in moments about origin. Minus omega square by 2 e of x square is m2. Minus j omega cube by 6 e of x cube is m3 and so on. Now keep omega equal to 0. In this expression, okay, let it be phi x of omega and make it as equation number 1. So keep omega equal to 0 in 1. It implies phi x of 0 is 1. Okay. What is 1 in terms of mn? Moments about origin concept lo 1 everki vastundi. 1 is for m naught. So it is m naught. It implies m naught is 1. So m naught is equal to phi x of 0, which is nothing but 1. Then now differentiate this phi x of omega with respect to omega. So what you get? D phi x of omega by d omega is equal to, the first term is not involving any omega, so if you differentiate it, you will get 0. And the second term you have omega, so if you differentiate it with respect to omega, you will get jm1. And here you will get minus 2 omega by 2 into m2. And this is minus j 3 omega square by 6 into m3. Okay. Then in this expression, keep omega equal to 0. So what you are going to get, as these terms are involving omega, all these higher terms are involving omega. So if you keep omega equal to 0, all these terms become 0, you will be with only jm1. So it implies m1 is equal to 1 by j d phi x of omega by d omega. Okay, means 1 by j. You can write it as minus j is whole power 1. Okay, into d phi x of omega by d omega. Now, differentiate 1 with respect to omega second time. What's the meaning? You must do d square phi x of omega by d omega square. And 2 times differentiate cheyandi. అది కావాలంటే మీరు ఇక్కడ ఆల్రెడీ ఒకసారి డిఫరెన్షియేట్ చేశారు కదా, దీన్ని ఇంకొకసారి డిఫరెన్షియేట్ చేసుకోండి చాలు. ఓకేనా? సో ఇప్పుడు చేయండి, దీన్ని ఇంకొకసారి డిఫరెన్షియేట్ చేస్తే ఆల్రెడీ ఫస్ట్ టర్మ్ 0, ఇప్పుడు సెకండ్ టర్మ్ కూడా 0 అవుతుంది, ఎందుకంటే దీనిలో ఒమేగా లేదు కాబట్టి. ఓకే, సో 0. అండ్ ఇక్కడ చూడండి 2 2 క్యాన్సిల్ అయిపోతుంది, ఒమేగా ఉంది కాబట్టి విత్ రెస్పెక్ట్ టు ఒమేగా డిఫరెన్షియేట్ చేస్తే you'll get minus m2. అండ్ ఇయర్ 3/6 1/2 ఉంటుంది. ఒమేగా స్క్వేర్ డిఫరెన్షియేట్ చేస్తే 2 ఒమేగా అవుతుంది. సో టోటల్లీ ఇట్ ఇస్ minus j omega m3 అవుతుంది. And so on. Now keep omega equal to 0 in this. So ఈ టర్మ్స్ లో ఒమేగా లేదు కాబట్టి ఉంటే, ఈ టర్మ్స్ లో ఒమేగా ఉంది కాబట్టి 0 అయిపోతుంది. సో ఇట్ ఇంప్లైస్ d square phi x of omega by d omega square is equal to minus m2. ఈ మైనస్ ఎలా రాయొచ్చు? j square m2 కదా. సో what it implies? m2 is equal to 1 by j square d square phi x of omega by d omega square. So you can write m2 as minus j whole square d square phi x of omega by d omega square. Okay na? So ఇది చూడండి minus j power 1 into d phi x of omega by d omega వచ్చింది. ఇక్కడేమో minus j power square minus j power 2 d square y x of omega by d omega square వచ్చింది. అంటే ఇదేమో m1 కి ఇక్కడంతా 1లు ఉన్నాయి, పవర్స్ 1లు ఉన్నాయి. m2 అయితే ఇవన్నీ పవర్స్ 2 అయినాయి. సో similarly if you find mn, what you're going to get? You're going to get minus j whole power n. ఇక్కడ ఎలా అయితే 2 వచ్చిందో అలానే ఇక్కడ కూడా n వస్తుంది. అలానే d power n phi x of omega by d omega power n అవుతుంది. Okay na? So this is the derivation for the nth moment. So this is at omega equal to 0. ఏవైనా సరే ఈ m1 అయినా నెక్స్ట్ ఈ m2 అయినా ఈ విషయం మర్చిపోవద్దు. We kept omega equal to 0. Okay? Hence we derived this mn expression. Okay, so this is all the derivation. Okay, once you go through the derivation carefully. So thank you very much. In the next video I'll go for moment generating function.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.